All right, looks like we're ready. All right, what's going on? So for this problem, we have a hard problem here. So I've been working on it. I think I learned how to do it, so I'm gonna try to implement. I had to do some reading on topics. So the main thing is is just collision detection. The name's kind of misleading, but really is point in a polygon, and this is also a problem on CSAS, point in polygon. Well, anyway, it's a pretty well-known computational geometry problem. So we're going to do this. Oh, I'm not logged in. Um, and see what happens. So the same as this. It's called collision detection, but it's really is a point in a polygon. Probably I mean, whatever, they made it, I mean, the same wording here. It says, um, eh, eh, yeah, okay. All right, so what we can do here is set the problem up. So first thing we might want to do is, so we're going to want to use, to make the computation easier, we're going to want to use um, a struct that I'm just going to call P. And what this is, basically what this struct is going to contain is, it's going to contain the x and y coordinates, because in this problem, that's what we need. We're in a two-dimensional space with this two-dimensional polygon. And I'm gonna use long x and y just because I want to avoid if there will be an overflow. And then I probably need some type of, actually I don't think I need an init function. Um, unless I'm gonna use that. But first things first is, well, actually that's the first thing. So I have that thing. Now what I'm gonna do is basically create these. So I'm gonna say I'm gonna create a poly. Mm, okay, actually, maybe I'll call this PO, and then I'll call this, I'm gonna make a vector of points that's gonna make up the polygon. And then all we have to do is say for vector int v vector int, oh wait, I can't do that, v in PO, and then I'm going to say pp, just some point, yeah, p for point is going to be equal to v0, v1. So it should give the x and the y value, and then polygon dot pushback p. So I've just basically made a vector that contains this struct. Should make our lives easier later on. Now what we want to do is check if there's, so the main idea that I'm going to use, I'm going to draw it later, I've already drawn it on paper though, is I'm going to check if there's an intersection. So I'm going to count the number of intersections. If the count number of intersections is odd, or is odd, right? So we return, um, if it's odd, that means it's, the point is inside the polygon. So return true if it's odd. If my count is odd, that is the number of intersections. If the number of intersections is even, then it's completely encased in the polygon. And then what we have to do is say for int I equals 0, I less than n, I plus plus, and then well, this doesn't matter. We could go 1 to n, and then I'm going to get my second point this way. No, okay. So I'm going to have my 2 points. So first thing we want to check is intersection. So I need a function that's going to check if it's an intersection when I have a polygon. Let me think. I'm gonna actually just create this one too. But yeah, so you have your actual point, you have your polygon, your point on the polygon at I, and then you have your point on the polygon. Sorry, I'm gonna have to do I modulo n, and then point on the polygon that's gonna be I minus 1, and I know I don't need to do modulo n because I'm only going to go up to n here. So that should be fine. And this should probably have to be some type of if statement. So this is going to check if it's an intersection, right? Yeah, I want to check if it's an intersection. And if it's an intersection, we want to increment the count. So that's it. Now, is intersection, Boolean is intersection, is going to take a point P, a point B. I don't know what name to give these, so just do this. So to check if something's an intersection, we have to use this cross product thing. So we're going to say sign, so I'm going to say S1, Boolean S1 equals if, I guess, oh, right, when we check an intersection, by the way, I need to actually make a line. So normally you take 4 points. So actually P and D. So my second point though is it's going to be a weird one. Because I'll call it like my limit. It's going to be x plus 1, and then I don't know if I need to do that. Maybe some kind of large number, and then this would be my limit point. I don't have a good name for it. And then we check the intersection between these points. So we need to get long S1 is going to be equal to do subtraction on these points. Now, what I'm doing is I'm basically making vectors by doing this. So I'm going to make a vector with this, and then this multiplication. It's going to be interesting what the multiplication is actually going to be. And then I guess C minus D. And then I guess long S2 equals wait, hold on. See, S2 is going to be equal to trying to think here what I'm doing. Oh, my water's far away. Crap. I got thirsty in the middle of this. Okay, and I need it. My brain. So what happens when you take one day off? Kinda. Well, not even one day, but just half a day. And okay. okay, yeah, S2 will be, so this is a vector from here to here, and then you have one from here to here. Oh. This should be minus A as well. And then this one will be B minus A times D minus A. Those will be my two signs. And what I want to do is I want to say, hey, um, if, oh, you know what? These should actually be Boolean. And so this is basically like, hey, is this greater than 0, I guess? And it's like, hey, is this greater than 0? So basically if S1 and S2, so what's going on here is that both these are true, which means that this point is like completely to the right. Or you can have the case where they both are false. The only case you cannot have is you can't have, oops, what can't have S1 not equal to S2, if that makes sense. So in reality, what I'm doing is I'm saying that S1 is equal to S2. That is that they are both true or they're both false. So we can do that here. So if they're equal, which means that it lies complete, that means there's no intersection. So that's when we want to return false. So get rid of this thing, else, return true, right? Now, okay, gonna want to do this a little bit more. We're gonna want to actually do this 2 times because we have to check if one line is like completely to the left or the other line is completely to the right to be able to actually check if it intersects. I'll draw that out. You have to draw it out to be able to understand that. So I say for int rep equals 0, rep less than 2, rep plus plus, repeat repetition, I guess. And then do this. And basically I return false if this ever happens, but at the end we need to uh, swap A with C and swap B with D. So basically you swap the places of the lines. So now you're considering the other line segment. And so it's like with one line segment you're considering, okay, I'm considering this line segment and this line segment, and I'm considering like, is this line segment completely all the way to the left? This also has to do with belonging, I guess. Everything I'm saying doesn't make sense right now, but it will at the end. So do that, and then yeah, and then return true if it is intersection. So I should check if it is intersection. Is that it? Oh, right. I have to actually make these operations. So one operation I'm going to need is I need the ability to subtract 2 points. So and return a new point. So I need this ability to do subtraction of 2 points. Oops. P and B. And so subtracting 2 points. Why do I want to be able to do this? Because this is a vector. If that makes sense. You can construct a vector from 2 points. In a sense, or yeah, that's pretty much what I'm doing because I'm going to do a cross product. So this subtraction, I wanted to return a new point that contains, let's say bx minus ax and by minus ay. Okay, so this turns a vector, so now this is a vector. Now what I want this to do is I want this to do a cross product, but it's not a normal cross product. It's not gonna yes, it's taken in two vectors, these a two-dimensional vector. But what this should return, this multiplication operator, it should actually return a it should actually return just an integer because it's just going to return the z component because that's the only component we're worried about in terms of determining if it's intersection or not. So it should return long long and well, it's going to be operator multiplication. Uh, Whenever you have something like this, so what I want this to return is basically a dot x times b dot y minus a dot y times b dot x. That's just the cross product. So that'll take the cross product of these two. Okay, I think that's it. Oh, what? What's the error? Error no match for operator minus. Operand types are const p and const p. I don't know what it means by that. Maybe it has to be up here. It says error p operator must have either 0 or 1 argument. Wait, I don't know. No. Yeah, I want it here because if it's here, it has to be a method of this point, right? Mm. Oh, yeah, that was my error. That error message wasn't helpful. That if I didn't know better, that error message was not helpful at all. Did not say I needed a semi, but I mean the helpful part was I knew the error was happening like around this area, I guess right before it. This error is there's a swap error. What's the problem? It says no matching function for call to swap. So if it's a constant, because swap I think swaps like the variables. Okay, so maybe it's constant, you can't change it. That makes sense. And since I'm trying to change it, these shouldn't be constant here. Okay. And this is a semicolon problem. Um, okay. Um, doesn't matter. What did I do wrong? Should pass this test case. Printed out one. What? typo. I accidentally added an equal sign. Okay, so it works. And now we're going to submit. It's not going to pass every single one. Okay, Phil's here. Why? Let's see. It's hard to visualize where these points are in the two-dimensional space, but this 1, 4, the 1 lines up with this one. 4, oh well, this is like, well, here to here to here to here, then back to here. Okay. Ah, that's the wrong one. Okay, 0. Make sure this could have overflowed. Let me make sure I am doing long everywhere. Could this overflow when it does 4 times? Yeah, it overflows. Can I do this and declare this a long? No, I can't. Okay, so I have to do 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so the problem there was the overflow. Still wrong. Okay, yeah, that should work. Okay, so 4 seems to work with that. What I can do is look back up here. The previous point is the current point. Okay, where should I look for any errors? Order of operation here. I'm not sure what the order operation is here. Let's I don't know what I'm doing. And then just convert these to longs. And make sure that I know which one this is. So I can count the heres. The problem is that it's returning false somewhere. So if we look here, this one is going to, this one's going to return false. This one will return false. This one will return false. This one will return false. So only the last one is going to work. And that's 40 to 55. So that's going from here to here. And x is at 1. But y is at 4. What? What's this 5 here? The fuck? Oh, well, yeah, anyway, oops, I cussed. Well, sorry. Just trying to think here because the problem here is so I can tell this one should return true. I'm not sure I understand why this one should return true, unless if I print out try that. What? Oh, I forgot that I'm going from 55 to 50. Okay, and then what if we did? So it seems to me that this works right here. This works. But if we want to do this as Boolean, I want to say this is greater than 0. This is greater than 0. What do we get? What the frick? What? Look at this. Okay, this one makes sense. The frick is this doing though? Why is it Alright, I don't know what this is. I'm really flabbergasted here. It's using limit though for this part. Huh. It's interesting. Okay, anyway, okay, I'll ignore that for now. But let's just look at this. Um, D, D, okay, so, but anyway, this point is, S1 is 0 and S2 is 0. But I know that shouldn't be the case. So here they're long, long. something changes the I value here. What is going on? It might have something to do with this swapping. This is the 5 one. 5 and 5. Okay. Should be taking uh should be taking 0 though. I know what the problem is now. It swaps them. So normally you don't want to reconstruct and you want to pass in the reference, but in this instance, I don't want to pass in the references. And I mean, it's kind of weird, but that's what the problem was. Okay. Um, yeah, the reason I don't want to pass in the reference because when I swap it, it swaps the memory address. So what was at the polygon here might actually be the limit point. I guess at the end, I guess, yeah, 'cause I mean, you're actually swapping what's held at that memory address. So if I'm passing in these by memory, I'm not reconstructing a new object. Then it's going to swap around the memories because what makes up this polygon is that you have a pointer to these memory locations. And now this memory location holds, okay, it holds the limit point. How did that happen? Because we were swapping the pointers, what memory location they're pointing to, I guess. I don't know what words to use here. Okay, so that should get us over that hump. And now, oops. What the hell? How did that submit? Okay. I'm actually surprised that it worked. I thought I was gonna have to check if it was on the boundary too. Hmm. Guess not. Okay, I'm gonna submit with this. Maybe there aren't any good test cases. I'll make up a test case where it's on the boundary. Okay, let's take something really simple like this. Just let's take a square. And then put this at 3 and 3. So that's on the boundary. Yeah, so it returns the wrong answer. So obviously, because it says here, it says in the question, determine if x and y, determine if x, y lies inside this polygon or on the boundary. It says in the question or on the boundary, but this is on the boundary. I mean, it's literally at this vertex actually. Could do something not at the vertex too if I just change x to 2. That's on the line. Anyway, the boundary doesn't work. Vertex is the same thing as being on the boundary, so it doesn't matter. So this solution doesn't work. Somehow it passes their test cases, but it's definitely wrong. So I'm gonna have to report that. Um, Hold on, what was I doing? This is what I was doing. Okay, report this issue. Okay, so I'm gonna fix up my solution so that it'll work when I update it. Um, so, so we're gonna have to check if it's on the boundary or not. So if on boundary for P polygon and polygon I minus 1. So if it's on the boundary, I mean, just return true, right? If you ever find a point that's on the boundary. So go up here. We need a function for this. Boolean on boundary. Let's think, am I gonna be swapping these? I might be. So we only have 3 points. So the first thing we want to do is check really, to be on the boundary, you need to be collinear. So we need to check if it's not collinear, that is A, B, and C, return false. Okay, Boolean is collinear. Okay, I think I can use constants now. And if the cross products are 0, if the cross product is 0, it means there's no angle between them. So return if B minus A times C minus A equals 0. So that will check if it's collinear. To check if it's on the boundary, I do this. I pass it into here. But yeah, to check if it's on the boundary, um, we check it's collinear, and then we have to check. There's a trick to use, like to be able to find if the point lies on the segment, right? So you want to check if this point A lies on the segment here described by this. And to be able to do that, we just need to create like a bounding box based off these 2 points and just see if P lies between it. So we just say return if if the if P is greater than or equal to the min. Sorry, this is A. If A is greater than or equal to the min of b dot x, b dot y, and A is less than or equal to the max of b dot x, c dot x. Well, this should be x. So this is x coordinate. So I'm checking if the x coordinate is greater than the min of these two, and that the x coordinate lies less than or equal to the max of these two. And then we do the same thing for y. Okay. That's actually it, I think. Missing the colon. Yeah, so it's accepted. I'll make sure that passes all the tests. Okay, and still pass all the tests. So, now we can improve this a little bit. So one thing is I noticed that these can be references, so it doesn't have to create copies. I mean, at the end of the day, like it doesn't really matter for this problem because it passed. So and it's really fast, and that's probably because the test cases aren't. I don't know if they're what's going on there. But anyways, I can make these constants so the compiler knows that these are not supposed to change, and these are supposed to be references. And here the same thing. I'm gonna make these constants, and then this shouldn't change, and this here shouldn't change, and then yeah, okay, okay, and then this thing. I think can be in here. Now there's, oops, I submitted. Actually no, it shouldn't be in there, because then I have to, like I have to say this point dot this operator or whatever. Okay. Okay. Checking everything is good. And yeah, I think constant Boolean makes sense because you don't ever want to change these values. The result of this output, the long, I think you might want to change that. So I would never label that constant. There's nothing here forcing me. Okay, so I'm gonna submit this. Okay, same fast. So what I'm gonna do now, I guess, is go over the math that was involved in using this. Uh, Actually, and this is the weird thing, I've already done this, but it didn't work, so I already have it. Just give me a sign in. See it, I already tried collision detection, and then we go to here. So this is me working out the mathematics. Well, I was recording, but the recording messed up. And my laptop's gonna explode. Not, it's not gonna be able to load this. But yeah, I don't think I'm gonna actually submit this one to public channels.